Hi, my name is Gerd Wagner from Brandenburg University of Technology in Germany. I'd like to claim that web-based user empowerment is the future of ABM. ABM users suffer from several issues. With many current ABM platforms, simulations cannot be easily deployed on the cloud-based web. Typically, they are only available on a desktop computer. Usability is often neglected. This, of course, is due to a lack of human resources, and programming the core of a platform does not include user interfaces and usability issues. So typically there are poor or even no user interfaces in many ABM platforms. There are only poor or even no support for user interactive simulation. This is a form of simulation where users can interact during a simulation run with the simulation, which helps to get users more involved and helps them to understand a simulation model. No-code or low-code users are generally not supported because all ABM platforms require heavy coding. This is an issue for many social scientists who don't want to get involved in coding, or at least not in heavy coding. Even heavy coding users have issues. They need to struggle with the deficiencies and incompatibilities of today's ABM platforms. Typically, each platform is using its own idioms, its own language, its own architecture, and there is almost no compatibility and no interoperation between platforms. So heavy coding users need to struggle with insufficient support of general simulation concepts. For example, time models. Users would like to have support for a choice of discrete or continuous time models. They would also like to have support for a choice of space models. And they may want to have a predefined concept of experiments, such that they can deal with experiments. The same applies to predefined forms of visualizations or animations and user interactions. Very often there are only limited or even no predefined features for these standard simulation concepts. Typically, there is also a lack of a clear or even formal semantics. There is some form of intuitive understanding of what the simulator of a given platform is doing, but there is no standard approach how to define this or how to explain this to users. This is related also to a lack of model compatibility and platform interoperation. Making a model in one platform doesn't allow to transfer this model to another platform in a well-supported manner. Typically, such a transfer requires redoing the entire model. And this is related to the fact that there is almost no support for interoperation between different platforms. No-code, low-code users would like to be able to define simulation items with the help of user interfaces and not by writing code for these items. Important user interfaces for these users would be a user interface for defining initial states, such that a user can define and maintain several alternative initial states for the same model. Also, a user interface for defining the output statistics would be important for no-code, low-code users. Similarly, simulation experiments could be defined without coding, and in that case, no-code, low-code users would be able to define their own experiments. Very often, simulations are only accessible and in a quick manner if they come with a certain form of visualization. A visualization could be defined on top of a simulation model, and this could be done with the help of a suitable user interface, such that no-code, low-code users would be able to define their own visualization. The same applies to the issue of defining user interactions, which would, for example, allow to control an agent in a simulation run. Also, these user interactions that could be defined on top of a simulation model should be definable with the help of a user interface, not requiring to write any code. Our simulation platform, called OES.js, allows web-based simulations, and it has the goal to support no-code, low-code users by providing a number of user interfaces that allow to define simulation items without coding. OES.js is a JavaScript-based implementation of the object-event simulation paradigm. It represents a general discrete event simulation approach based on object-oriented modeling and event scheduling. In OES, a model normally defines various types of objects and events. But OES also supports models without explicit events, using fixed increment time progression corresponding to implicit time events, also called ticks, like in NetLogo simulations. OES has a formal or operational semantics, which you can read in a paper that is available on the sim4edu.com website. The next version of OES.js, which will be available in 2019, will support a concept of agents with perception, action, communication, and a cognitive state. These features will be useful for simulations that require a rich concept of agents. Of course, simulations that require only a basic concept of agents can be made with the help of objects in OES version 1, like in other platforms where there is no distinction between objects and agents. I would like to invite you to try our platform OES.js out. You can find all the resources, simulation examples, and the simulation framework code on our website sim4edu.com. We also have the Schelling segregation model as an example, and Langnick's baseline economy, which is the simplest model of a full-fledged economy. Both models can be executed from our website. Please try it out. Thanks.